So we're actually live. Well, we're trying to live stream this to Twitch. So of course, right as I tell you guys to sit down, we run into technical difficulties, but it's okay. We'll get this sorted. My name is Chris, and I work at Zilliz, and I want to welcome everybody here to the Unstructured Data Meetup. Thanks so much for coming. Can we turn the music down? Who came to the meetup last night at GitHub? Raise a hands. I know I see some faces. Yeah, I recognize you. So the good news for those of you that showed up last night, all the talks are different. So it's not going to be a repeat. For all of you that didn't go last night, all the talks will be posted on YouTube. In fact, they may already be posted on YouTube. So you get to listen to those talks as well. As I mentioned, my name is Chris, and I work at a company called Zilliz. And you can see the logos on various materials we have. So it stands for zillions and zillions of unstructured data. And we are the core maintainers of an open source project called Milvis. And as any good open source group of people, we named it after an animal because that's what you do, right? And Milvis is basically a kind of a like a falcon. So it can fly really fast, really high, really far, but it has amazing eyesight. And that's really important because what we want to do is help you to get insights into your unstructured data. And so this is, so that's what our project is. And one of the things that we're going to do tonight is we're actually going to have a raffle. We had a raffle last night. And what we're just asking you to do is if you can be so kind and take a look at Milvis and star the project. And then we will collect the names. And at the end of tonight, we'll do a raffle. We're actually going to have 3 winners tonight. And the prize is there's a conference next week, the Gen AI Summit in San Francisco. And so 3 full passes is what we're giving away tonight for that in exchange for some stars. So I really appreciate that. I also want to thank our incredible hosts, SAP. I mean, this place is gorgeous. I don't know what you guys think. We're in the middle of a redwood forest. So I really want to thank them for co-hosting and also providing the amazing food. GitHub was great last night, but all we had was pizza. And so this is amazing. So fit under the AI umbrella, hit us up. We'd love to share your projects at one of these meetups. We also do this in Berlin. We're starting New York City next month and also Seattle. So, and like I said, it's all about community building. It's not about, just beating our chests about how amazing Milvis is, even though we are. We really do want to make sure that we build out a really great community. Okay. I've got all these things. Cool. All right. I am going to now pass the baton to my boss and the CEO and founder of Zilliz, and this is Charles. Charles, you ready? No, he's going to be IT guy and help with the Twitch stream. Yeah, this is my laptop. Okay. All right. There you go.
Thank you, Chris. First of all, I really want to thank you for joining this meetup in this beautiful place, in this beautiful weather. And yeah, so please allow me to take a chance to give a brief opening about this meetup, and then we will have another 3 wonderful presentations. Yeah, I'm Charles Xie. I'm the CEO and founder at Zilliz. And also, I was the creator of the Milvis project. Before I founded Zilliz, I was one of the founding engineers of Oracle Cloud Database Systems. And so nowadays, we all talk about Gen AI. So, but if we take a closer look at Gen AI, it has 3 pillars. It's all about computation, it's all about models, and it's all about data. So we know that there's a lot of companies, a lot of hype when it comes to computation and the models, right? So it's already heavily invested and heavily hyped space when it comes to computation and the models. But when it comes to data, compared to the other 2, not that much. But if we take a close look at the data, we will find out that the data we are going to process in this AI era is very different from a traditional data processing. So traditionally, we have a relational data, we have all these numbers, we have Oracle, we have tables. But nowadays, when we are talking about artificial intelligence, we are talking about most likely natural languages, text, images, videos, user profile, geospatial information. Even in pharmaceutical area, a lot of researchers they are studying the 3D structure of molecules, 3D structure of proteins, and all these kinds of unstructured data is so important. And so, when it comes to unstructured data processing, that something top of our mind is a vector database. So yeah, so as a vector database company, let me take several seconds to briefly cover what is a vector database. So basically, vector database is a purpose database system to make sense of unstructured data. What it stores is embedding vectors. And what's stored in these embedding vectors are these semantic presentations behind all this unstructured data. So with the vector database, we can query all kinds of unstructured data by semantics. So we can query, a lot of images by the people showing up in the picture, by the scene in the picture. So we can even query all these videos by the scene, by the characters. So so we started in year 2019 building the world's very first vector database system. And over the years, we get more than 5,000 enterprise users, and we get more than 25 million downloads and installations. And for those of you that who want to get something out of the box, and we have this cloud, which is a fully managed cloud service built on top of open source Meerverse. So, so we were talking about a vector database, but in my opinion, that if we really want to get into this revolution of unstructured data processing, vector database alone is not going to work. What we need is an ecosystem. We need a collective efforts. So, the way I saw is that there's tons of opportunities in this unstructured data space. Basically, every single technology, every single product that we build for structured data, we have to rebuild it again for unstructured data. There are opportunities for unstructured data security, unstructured data compliance, data observability, even data encryption. I know that there are a lot of companies that are in Silicon Valley, they are working on the new ETL for unstructured data. So they are basically converting unstructured data into embeddings, and they are working on data pipeline. And so there are tons of opportunities over there. And still, so compared to computation, compared to models that are the unstructured data space is a little bit quiet, in my opinion. So that's why 1 year ago, we had this idea that, we are going to make some noise, so we are going to get, to get people's attention in unstructured data. That's the idea we want to host it. We want to build this unstructured data meetup. So our mission is that we really want to foster innovations and collaborations in the space of unstructured data processing. And in the past 12 months that we have made a little bit of progress. So now we are opening, a number of chapters. So it was 12 months ago we started in San Francisco, but now we get around like 6 chapters from San Francisco to South Bay, Seattle, and we just had a new one in Berlin. And later this month, we are going to have another one in New York City as well as in Shanghai. So the idea is that we really want to build a community that everyone can share their ideas, share their best practice, and also can collaborate. And so in my opinion, the future of unstructured data is it's not just in the technology itself, but it's also in the community we are going to build. And so that's my opening, and you know, so and I hope you know, you guys enjoy the food and the drinks here, and also enjoy the wonderful presentations today. Thank you.
All right, Jiang, you want to get set up? Okay, Jiang, I already kind of introduced really briefly. So he is in charge of actually a couple of things. So he is our responsible for our ecosystem partnerships, but he's also the product manager of Milvus Lite, which we just released yesterday, but we'll do a formal launch next week. And so he's a pretty busy guy. And today, what he's going to share with us is a little bit about Milvus Lite, but more importantly, you know, everyone's talking about RAG, and we've seen the same old demo over and over and over. And what he's going to show is there's actually a lot of different approaches that you can take. And so he's going to kind of walk through a couple of different techniques and hopefully get you guys inspired to try a little bit of a different approach.
All right. Good to know you, everybody here. My name is Jiang. I'm the, yeah, it's really hard to define my role, but I kind of see it as I want to make the developer's life easier and better by doing two things. One is that we make the Milvus offering, which is the open source vector database, extremely easy to use, extremely like intuitive and straightforward. We also work on the commercial offering, which is called Zilliz Cloud, and we build not only vector database, but also kind of the embedding model, like machine learning capability into it. We streamline all the components that you need for the AI-powered search. And we provide them as, you know, again, easy to use API service, and also reliable and running 24/7 by our SRE and DevOps folks. So today's topic is about fantastic RAG techniques and where to find them. I guess RAG is not a word that people find kind of strange, but like 6 months, 12 months before this, RAG was kind of a new technology. So over the last year, RAG has evolved a lot. So I guess like 6 months ago, if you talk about vanilla RAG, there's still someone like interested in listening to that. But nowadays, talking about vanilla RAG, it will be boring. So I want to kind of fast forward a bit and talk about the, you know, the advanced techniques that can boost your RAG quality or your user experience even better. And more importantly, a kind of systematic mental framework to think about how to improve the RAG quality. So everything about RAG kind of come from the fact that large language models are great, but they kind of hallucinate a bit, right? It's not great for everything, even though it's super, super impressive that it has reasoning capability whatsoever. And to battle the hallucination, you still need the retriever, which is just like a Niffler in the Fantastic Beasts movie. It can retrieve something for you, right? It can retrieve the golden mine of data for you. So what makes this possible is the new stack of semantic search powered by deep learning and neural networks. So the idea is that you can, you know, convert your data like unstructured, like text or image or videos, voice, or even structured data with a vectorization mechanism, which is an embedding model, a machine learning model, which has a lot of cells. It can form as a network, and then it can generate a bunch of numbers, which human doesn't really, cannot really comprehend. But these numbers will be the mathematical representation of the signature of the data, so that you can use this data to compare the things and find the similar things, like similar in the sense of they have the same semantics, so that you can do search on top of that, rather than mechanically compare the keywords of the text, which is what Elasticsearch and BM25 was doing for the last 2 decades. So today, I will start with reviewing the RAG basics, because we want to start from the very beginning of this technology, and then I'll introduce a bunch of ideas or like approaches of improving the quality of the RAG system. And then lastly, if we have time, I will show some code to see how or Milvus and the just released Milvus Lite offering can help these things and make it easier to build RAG, and how you can use this with frameworks like Llama Index, LangChain to build a very advanced RAG pipeline. So as I stated before, the large language model is great, but it has a few drawbacks. It hallucinates. It cannot get access to your private data, because you don't want the OpenAI to train on your very precious proprietary private information of the corporate. And it's really difficult to manage the information in large language model, because it's kind of a junk of like everything, right? You cannot take something out and then say set access control list on that, so that your users can access this piece of information, but not the other one. However, if you use RAG, because it's just a database, like vector database, which organizes the information so that you can apply data governance on top of that, that gives you a lot of flexibility to implement the business logics of your application. And there's also fine-tune, which is another way to improve the large language model. But fine-tune is really like limited in the sense you probably need to hire a machine learning team to do fine-tune alone, because it takes a lot of like expertise and techniques to make it right. It's also very expensive, and also you cannot fine-tune it every day, because it's just too expensive for it to be economically viable. So you have to make it very kind of sparse. You fine-tune it every 6 months or even 2 years, and the data will get outdated very soon. So that's how RAG come to play, that it can improve the large language model and also give you a lot of access to the flexibility and improve the quality of this technology. The idea is very simple. So it basically applies a search on top of large language model. So you have your data like internal PDF documents, internal images. You want to on the bottom left, and you want to use some machine learning model to generate the vector embeddings out of it, so that the vector embedding will be the representation of the data, and you store them into a vector database like Milvus or Zilliz Cloud. And then once you have this data, at retrieval time or at serving time, when the user asks about some question on your chatbot, like UX, you can route the query to the same machine learning model, which generates the representation of the query, and then use the query to do vector similarity search to search for like semantically similar content from the vector database, and then compose a prompt with some instructions, such as just use this information to answer the question. Don't be creative. Like if you do not know, don't make it up. Just say you don't know. And then you append all the retrieved information at the bottom. And then you send the information back to the large language model, and it will generate answers. It will basically leverage its reasoning capability, and then it will summarize the information. It will do some reasoning. You can make this really fancy, like you can apply an agent on top of that, which we'll cover in a bit. And then you have a very reliable, high quality answer. And that's all the goal that we want to achieve. So sounds great, right? But unfortunately, this doesn't really work well in production or in real world, because usually you don't have like high quality data to start with, or you figured even though you have the data, but it's kind of hidden somewhere very deep in the PDF file, and your chunking logic, like you have to do chunking before you run the embedding model, because it can only take a very limited context length, like or a limited size of text to process, so that you have to kind of do a lot of pre-processing before you can even run it through the machine learning model. And that's a very tricky thing, which we will talk about how to improve it. So a lot of things need to happen here. But before we go into the fancy techniques or tricks, I want to first mention something that's not very interesting, which is the concept of continuous evaluation and iteration. So I worked for Google search indexing for like 5-6 years. The biggest lesson I learned is that if you cannot measure it, you will never be able to improve it, because you don't know what you are doing here, right? You are just trying out magics and you don't know the consequence of that. So you have to develop this both the mentality and also the framework to say you have to define the metrics to measure, and you have to have data sets to kind of do the measuring, and then you have to have the quality evaluation kind of pipelines. That's another kind of pipeline to calculate the metrics, and then you need to count the metrics, do some like analysis, figure out the improvement ideas, apply the improvement, do A/B testing. And then finally, you probably will get like bad results, because sometimes those improvement techniques can lead to even worse results, right? But luckily, out of like 10 attempts, you maybe have 1 or 2 like good attempts, and then you can apply that to your production system. And even after that, you have to continuously monitoring this thing, because it could have some regression in production. So only with this mindset, I think it's meaningful for us to talk about the improvement techniques. The way that we want to approach this is that I like the idea of divide and conquer. I want to divide it into like a few pieces of components, right? Just as we said, it has the indexing part, which is to organize your data and then generate vector embeddings or representations, build an index so that you can search from it very efficiently. And then you have the querying side, querying step. And then the query will lead to retrieval, where you get the related information. And then with this information, you can construct a prompt and do generation with large language model. So the way we tackle this or improve this is by divide and conquer, and we deal with each individual component at each time. So for the query, we can enhance this by express and process the query intention, which is you can kind of interpret what the query is about. Is that 1 question, 2 questions? And also you can, we'll talk about some fancy ideas later. It will get crazy very fast. We also have the index, like the same idea applies to index, retriever, generator. I won't cover them one by one. But lastly, in addition to work on each individual component, kind of stay within the right framework, we can also be creative and think out of the box, which is using agents to help us do the retrieval and help us do the reasoning in between the retrieval process, and then do this iterative retrieval reason, that's called react. We'll cover that idea in a bit as well. So first, query enhancement. So user sends a query here, and usually we'll just take the query as is and then do the vector embedding and then retrieve that. However, sometimes it's just really difficult to comprehensively understand the semantic of the query. But you can do multiple kind of slight variations of the queries by generating fake queries with large language model, and then use fake queries to retrieve the content, and then you merge everything together, you kind of fusion them, and then you will get the best possible outcome out of them. The same idea applies to in the other kind of direction, which is you can generate fake answers for the query. Instead of generating queries out of queries, you can generate like bizarre answers out of the query. Why this help? Because usually the way you answer a question and ask a question are totally different, right? As a person, even a human being, sometimes they just doesn't look like, they just don't look similar to you. For example, I can ask about what is Milvus, and the answer will be a huge chunk of text talking about Milvus is a great vector database, it's efficient, it's developer friendly, like blah blah blah. But they are very different, right? If you just use your eye and intuitively recognize them, you will see, okay, one is pretty short, the other one is pretty long. There are a lot of nuance regarding this because you are using the same embedding model to comprehend both sides of very different types of content. So the idea of this is that I can make the query look more like the answers, which is to generate fake answers based on the query, right? So I could say Milvus is like document DB, which is not exactly true, but this kind of large content, like large chunk of data or text will look similar to the actual correct answer. So this, in some senses, it will help the retrieval quality, but again, use the evaluation because it doesn't always work. And there's another interesting thing is sometimes the query just asks about different concepts. And to take this query as a whole, you have to combine the context or kind of average them in some very hypothetical like sense. But you can break up the queries and make them two queries. A large language model is really, really good at doing this. For example, what are the differences in features between Milvus and Zilliz Cloud? That's really kind of multi-step problem, right? You need to figure out what's the features of Milvus, what's the features of Zilliz Cloud, and what's the difference between them. Maybe enterprise readiness, maybe something else. And then the large language model will help you both on the subquery generation and the eventual answer generation as well. So that's about query. And for index, we have, I kind of believe in this simple principle that garbage in, garbage out. Right? If you don't have good data to search from to begin with, you probably won't have good answers. So that's why we want to focus on the data first for the indexing part, rather than kind of try out the fancy retrieval techniques as a first step. So you need you want to collect a large amount of data in the first place, so that build your data kind of what's that called, like digitalization transformation, right? You need to be able to collect the data first, and also you need to do data cleaning because most of the data, say they are PDF files, they are scans of internal documents, right? They are not suitable for this kind of retrieval. You need to adapt them into some kind of format more suitable for the machine learning models and machines to comprehend. And then you also need to build some kind of techniques on how to parse the data, how to divide the chunks, how to separate the semantics between different paragraphs or sentences. That takes a lot of trial and error as well. And my long-term view on this is that right now, all of the data are generated so that they are easy for human to comprehend. They are human readable. But maybe eventually 10 years in the future, the data will be machine native, right? They are just vectors, or they are just something that we as human being doesn't really understand, but machine is really, really good at understanding them. I think that could be possible, but just a thought. For now, most of the data are still like human readable data, like PDF files. PDF is kind of the majority of the data that corporates generates. So that's why this concept of PDF parsing and smart chunking is very popular among the React developers, because that's a real problem. And there are tons of services and open source projects working on this. Other than that, once you kind of do everything you can on the raw data, then you can improve the mechanism of retrieving or organizing those data. For example, one thing is you can build hierarchical index, because sometimes the human readable data, they have the kind of hierarchy by nature, like they have different levels, topics, they have summary at the beginning, and then some kind of details after that, and then another summary to wrap up the whole paragraph. So you can, based on this idea, you can build a hierarchical index so that if you are lucky enough to hit a single piece of the information, then you can retrieve the whole part. Or sometimes is you can retrieve the summary first and then kind of expand them into more details, or is the opposite. But there's a lot of ideas to play with. And then comes, once you have good data, you can build fancier retrieval mechanisms. My personal favorite is this concept of hybrid search, which is pretty much just stacking things on top of each other, right? If vector search doesn't solve everything, you add, say, BM25 retrieval, which is the old, not that cool technology. There's also another concept called learned sparse embedding, which is kind of somewhere in between the very mechanical BM25, which is keyword matching, inverted index, and the super fancy machine learning model, like fully machine learning native embedding retrieval techniques. And there's also another kind of favorite technique I can think of is the graph database, or like PG, like knowledge graph, right? Because sometimes the information they have relationship between each other is not only like detecting the semantic similarity. Sometimes you want to know like who is the president of United States by looking up a graph, like traversing the information graph. And we have a fantastic partner like WhyHow. They will speak about this in more details. So let's take BM25 as an example, because most people are familiar with this. To make it enhance the retrieval quality of like solely vector-based retrieval, we can have this kind of two-way, like working in parallel. You retrieve the information from both of the paths, and then you use another mechanism, reranker. It could be naive, it could be another machine learning model, to kind of fuse those things together and pick the very best out of the two sources, and then combine the results, and then use large language model to generate the answer. And there's also a metadata filtering technique, which is if you want to kind of add guardrail to your retrieval, sometimes you just want to retrieve the information about a particular version of open source documentation. Like I just want to ask this question regarding Milvus 2.4 rather than Milvus 2.3. In that case, you can use this metadata filtering to help you restrict the information. And Milvus is, we did a lot of like hardcore engineering work to make this very efficient, so that it's not like you retrieve 10 things, like 100, top 100 results, and then you filter based on the filter, and if you get 90, you're lucky. If you get 5, then 4 day for you. It's not like that. So we will actually combine the vector retrieval and metadata filtering together, so that will retrieve everything possible for you. And lastly, the generator enhancement, which is, I guess before I got into this, I guess my, the thing top of my head on generator enhancement is to just wait for the next best large language model to come. Wait for another 2 months, and it will be much, much better. But if you couldn't wait for 2 months, you can do something like this. First of all, usually the way you compose the data here is that you kind of add everything together, and that will soon give you a super lengthy prompt, which will cost you like a lot to generate answer based on this, because large language model charge with by the number of tokens. So that you can compress the retrieval information, like doing summary in between, or just doing better filtering, say using a reranker to pick the very best top 3 out of the top 10, so that you reduce the amount of token consumption for the large language model. And also what comes with this is that the more data or the more information you feed to a large language model, the more uncertainty they will have, right? If you have fewer data and you are confident that those data will be of higher quality, then better use fewer data. The other idea is that you can adjust the kind of ordering of chunks in the prompt. This is some kind of observation on large language model. There's no why, it's just observation. So the rank of the, say if you have 3 document pieces and they are with the same 3, if you kind of shuffle the rank, it will generate better or worse answer for you. And the kind of the takeaway is that you want to put the information like this, like very best on the very top, the second best at the very bottom, not at the second on the top. And then boom, 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 traverse the center of this, which is the kind of deserves the least attention from the large language model. So that's everything about the components or like divide counter idea. The other one is about agents. So that's kind of fancy and very futuristic. One of the ideas that you can have agent to think about the retrieval result and then do some step or kind of give feedback on that. And then maybe if the result is good, you do something. If the result is bad, you do something else. For example, you can use the tools to enhance the results. You can decide whether to do reg or not. Sometimes you don't need to do reg. The large language model is really, really well, really good at answering common sense questions. And you can also kind of route this information to different subqueries, given that you break the query apart based on its intention. So a lot of kind of advancements are happening here, but most of them are not production ready. So definitely give it a try, but I would say these things will take more time to get mature compared to the more mechanical techniques that I mentioned before. So lastly, enough talking here, huh? Let's see how this can, how our offering can help the RAG. So as a vector database, we're one of the centerpiece of the RAG technology stack. And we want to make it really easy to use so that you can forget about that. We don't want you to say, out of your 10-day like developer budget, you spend 9 days on dealing with vector database. That's the worst thing we want to see. We want you to focus on your business logic, applying those fancy techniques, building your RAG evaluation pipelines, things like that. And so that's the idea behind this very recent offering, Meals Lite, which is super easy to get started. You don't need a Docker or Kubernetes to get started. You just need pip install, and everything else will be the same experience as if you are using a remote Meals server running on Docker or Kubernetes, which is way more scalable. And you can use this on your laptop, on your like Jupyter Notebook, Google Colab, and even smart home devices running Linux. And then with this, hopefully you have polished your application and you want to launch it, and you can launch it with Milvus without changing a single line of code from the client application. Actually, I was kind of lying because you need to change the target from one to another server, which is deployed on cloud or somewhere like Kubernetes. If this is still too kind of too much like development work for you, we also have this streamlined retrieval pipelines for you so that you can do PDF parsing, like document chunking, embedding generation, vector storage, vector search, everything other than large language model generation, it can do it for you so that you just need to make a HTTP RESTful API call to this service and then get the results and send it to, say, OpenAI's large language model, and that's it. So lastly, I would like to show a very quick demo on what I mentioned before. So this is Meals Lite. Instead of like setting up a Docker, just pip install, and it installs both the client side logic and also the server equivalent logics for you. And then you can use the Meals compatible API to deal with this thing by, say, for creating a collection, right? You just need to instantiate a client with a local file which materializes everything, like every information, so that if you terminate this program, the data will still be there. And all of the data are searchable and they are in memory so that it can search very efficiently. And then you create a collection, and then you just, just specify the collection name and dimension of the vector, because there are vectors come with different dimensions. And then you can do other things like build your rag. For example, you can do search here. You can search for your embedded text. You can specify what kind of outputs to get out of it. You can also specify the filter expression, which I will show in the future. We have other demos to show this. And then the other idea about hybrid retrieval and re-ranking, this thing we built the demo with LangChain, so that with LangChain you don't even need to deal with that. You just get a Milvus vector store, and then you can start building. With this, you can use the BM25 retriever and the Milvus vector retriever together and compose a chain out of it. That's the way LangChain concatenates the components or steps together. You can send it, then compose a reg prompt and large language model, and then boom, you'll get the results, hopefully. However, in this thing, we also need a reranker to do the fusion and merging. So that what we do is that we concat, this kind of comes crazy, like you need to concat another step after this, which is the hybrid and re-rank retrieval step, and then use the final fused information as the context of large language model. And this thing will work in practice by, here's an example, which I want to show, give you a sense why it can generate different outcome. So with the vanilla rag, the question is which model use tools, and there was a few models mentioned in this machine learning paper. And one result shows the tools are TAMM, but fail to mention the very important information, ChatGPT and plugins, and OpenAI API function calling. The reason of that is in the retrieve the result of the vanilla rag, because there wasn't enough attention put to tools, so that there's a piece of text which mentions ChatGPT plugins and blah, 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 and tools. And also, I think it's Hugging GPT, not Hugging Face. So that piece of information wasn't given enough attention or importance. However, if you combine this with BM25 retrieval, which only cares about the terms and frequency, it kind of balances the outcome. But you can see that sometimes this can introduce undesirable outcome, right? Because sometimes balancing may not be a good thing. You don't want to balance the bad things. So it really depends on your particular case. Your mileage may vary in this sense. Okay, I think that's pretty much it. I will stop here, but we have the demos, for every single kind of approach I mentioned here, and I will post it once we finish the LangChain integration, which will kind of come in a few days as we wrap up the launch of Milvus Lite. And I will post it on my LinkedIn. I've been kind of busy dealing with my social network footprint. I have been posting all this information on my social. So great. Hopefully I can talk to you after this talk. Thanks, everybody.
Thank you. Thank you so much. Why don't we get set up? As Chris is getting set up, we have time for one question. If anybody has a question. No? Yeah. That's even better. Then we can go right into the next one. So speaking of ecosystems, the next one is all about knowledge graph. And I was going to read my little blurb, and I thought, oh, I think I might steal all of his thunder. So I'm just going to let him go through what WhyHow AI is all about. Thanks.
Test. All good. Okay. Hey, folks. Okay, all good? All right. Hey, everybody. Thank you, Jiang. We actually met, we haven't not met in person yet. We've spoken on Zoom several times. It's great to meet you in person. Funny enough, we also have a Harry Potter demo that we're going to be doing today too. So there's going to be a theme today. But great to meet everybody. My name is Chris. I'm one of the co-founders at WhyHow. A little about me before we get started. Background, kind of like John was saying, is a little bit all over the place. It's kind of hard to, I think, fully define my role. But background, mostly as a software engineer, solutions architecture, product management, eventually engineering management, previously a founder. So mostly throughout my career, I've had a lot of focus on like platforms, on infrastructure, on developer experiences. And I say all this to contextualize kind of why I got in this place in the first place. So I get really excited about really nice developer experiences. I love working with tools that are simple, that are intuitive and collaborative and controllable. And I think anybody that's built products in the platform space largely feels the same. So when I first started building the space of generative AI, LLMs, it felt anything but controllable, simple or intuitive. So that's kind of why I joined up with Tom and Xie, my co-founders. Tom, our CTO, is in the crowd here as well. And we founded WhyHow. So WhyHow, at our company, we build developer tooling that makes it really fast and easy and intuitive to create and manage and orchestrate knowledge graphs. And we're doing that for the purposes of making AI more accurate, deterministic, and explainable. So I guess quick show of hands. The whole talk was about RAG, but who here is actually doing RAG right now? Some, cool. All right, yeah, great. And maybe before I do that, who here has ever worked with graphs, like knowledge graphs before? Okay, basically the same number of people. It's funny, most people we talk to, they started using, or they maybe heard of graphs in their freshman or sophomore year of college, and then never touched it again because it was a tough experience, or there's never really a use case for it. But we found one here. I'd love to talk about it now. But like a lot of you all who have maybe worked in RAG, we started trying to build solutions for a variety of different clients using some of these vanilla RAG processes. One of the more motivating examples that I'd like to probably talk about, reference a few times throughout this talk, was we were trying to build a RAG system for an investment partner or investment client. They had a lot of LPs in their fund, and they wanted to answer questions about like, who are the LPs in my fund? How much money has each LP invested? What are the rights of each of these LPs? And a lot of this data was, as mentioned before, unstructured in a PDF format. So trying to solve this problem, we followed a very similar process like John mentioned earlier. We did the vanilla RAG. We take these PDFs, we convert them into text, we do some splitting and then chunking, we pre-process that data. From there, we generate embeddings, and then we upsert that into a vector store. Then we use natural language. We query the vector database with that natural language, and we get back a set of relevant chunks, feed that to the LLM, and generate responses. And it worked, right? Yeah, kind of. We had a lot of the same problems that John was mentioning, a lot of hallucinations. And I'm going to cover a lot of like what I think John was mentioning before. And we already discussed a lot of answers or solutions for these. But I want to kind of quickly contextualize some of the issues that we specifically were facing with this. So first, models, I felt, did not seem to really understand the context of the domain in which I was trying to ask questions. We have a client we were working with who had a lot of unstructured text, specifically in the realm of like parks and like recreational like documents. So PDFs that had a lot of like legal jargon, but also regulations for how to, I guess, rules for parks and recreation type data. Funny enough, like when I say the word vehicular capacity to you, like what does that mean to you? To me and to the LLM I was working with, it meant the number of people that could fit in a car. In this case, it meant the number of cars that could fit on a road. So when we talk about like the embedding model or the LLM for which I'm using to actually contextualize and then perform perform search on this data, it really has to be quite relevant to the domain in which you're operating in. Another example we like to talk about that's been blogged about before is what is rice to a farmer versus what is rice to a chef or a nutritionist or even somebody that owns a grocery store. A farmer may care about the seeds or the plants or the sunlight or water exposure, whereas a chef may think about, okay, what is the fluffiness or the texture of this rice or the color? The nutritionist cares about, I don't know, like calories or gluten content. I don't know if that counts, but the context for which you are trying to understand the semantics of this content is different per the domain that you're operating in. Next, we ran into a lot of problems with trying to account for varied types of queries. We were working with a travel client who they were building a RAG system to be able to help people do wellness travel. So they had a lot of itineraries and options for travel where you could basically talk to it, get recommendations for where to go to. So questions like, I want to go to London, or I want to go to a Italian beach were one spectrum of the questions they would get. And the other spectrum, there were people asking questions like, hey, I'm kind of stressed out about work these days. I'm thinking about taking a vacation or doing something new. How do we build embeddings and chunks to be able to handle these types of queries, all these various different types of queries, but also how do we build retrieval systems that are going to be able to answer those questions? John mentioned a lot of really good solutions for this, but this is one of the motivating examples that kind of got us into working with knowledge graphs. Similarity and relevance are also, I think, kind of like a difference that we like to call upon as well. So another type of example is we were working with a different type of kind of travel client who was trying to help people find homes or places to stay on vacation. So when I say, like, I want to type in, I want to stay in a beach house. Are we staying in a beach house, like a beach like a mile from the beach, or are we staying at a beachfront house where I walk out and I step on sand? Quite semantically similar, but like realistically actually quite different and quite in cost, but also experience. So the domain and the context really mattered a lot here as well. Difficulty in building comprehensive responses. So back to that example about the fund that had a lot of LPs working with them. One of the questions that we may want to ask is how many LPs or who are all the LPs in my fund? This is a bit of a tough question to answer when you're leveraging top K. So if we have, for example, like 100 clients that we're working with, and we then chunk this into maybe chunks and then do a top K 20 retrieval, I'm probably gonna get back 20 correct answers, but what about the other 80? On top of this, we had to also handle much more complex queries as well. So not only were we trying to answer questions about all the LPs in the fund, but what about, and I think maybe the more interesting types of questions that people try to answer in this space are not just like who are the LPs in the fund, but who are the LPs in the fund who have invested at least $10 million and also have special data access rights. This type of query is one that, like John was saying before, can be broken up into several different types of queries, which is a really great way of solving this problem. But we also found that by doing that, we often ran into issues where maybe one agent answers a question like with 95% accuracy. But when we have maybe like 3 or 5 different agents doing this, then you have like, what, 0.95 to the power of 5 accuracy. That's like probably 77% accuracy. So pretty close, but when we have like use cases like legal or healthcare or finance, accuracy is required. And this is a thing that we really need to make sure we are doing correctly. So quick plug for all the different solutions that John was mentioning earlier. These are all really relevant, great solutions in this space. But our approach was a little bit different in this space. And we're thinking about how can we do this? We're going to probably just take this data, we're going to put it into small, well-scoped knowledge graphs, and then let our LLMs talk to that data. So through our insights in working with these knowledge graphs, we found a few different things to be true. One, working with many different small knowledge graphs is better than trying to work with one very large knowledge graph. Traditionally, large knowledge graphs are are the way of it. You have a graph that maps a very complex, cohesive domain and can kind of map out an entire system. What we found, though, is that by breaking a problem into very well scoped, very small graphs that you can answer on a per use case or per agent basis, it really reduced the amount of nefarious information entering the context window, reduced hallucinations, and broke down tasks into much smaller pieces that an LLM can handle better. We also found that LLMs just help you do all this stuff really fast. One of the problems with building or interacting with knowledge graphs now is it takes a long time. As Tom can attest to, building a graph takes a long time, not just in the actual engineering, but aligning with a lot of different people, taxonomists, domain experts, engineers across your organization. What is the right way to represent my data semantically? LLMs now are here, and we are able to basically quickly iterate on building small graphs and do this a bunch of times until we're able to build a graph that solves our problem. So we can now leverage graphs to do this use LLMs to build graphs in a much faster way. Graphs should be scoped to your view of the world. So back to that example about the rice of the farmer versus a chef. Your domain, your tasks, the things that you care about should be the things that you're mapping so that the information going into your LLM is hyper-specific and focused on the problem that you want to solve. And then lastly, what we found is, and what we're going to be able to hopefully demonstrate here in a second, is knowledge graphs and vector databases are not necessarily at odds, they're actually force multipliers. One of the ways that we've been able to leverage Movis is to be able to use it to construct graphs from relevant chunks of text that we've been able to use to build into a graph, but then also use our graph to reference text that is sitting in a vector database to then pull it back out and then give to the user as part of like a much more explainable workflow. So some of the benefits of augmenting your RAG process with these knowledge graphs. You have much more structured grounding of these answers. You're able to give LLMs just the information that they need, rather than an entire corpus of text that may or may not be relevant to the answer. One of the examples that we've worked with in the past is we have a veterinary radiologist, for example, we work with. The veterinary radiologist, their process is they wanted to build a RAG solution where they would look at a reading from an imaging reading. They would inject their opinion as to what this image was saying, and they wanted to then reference textbooks or previous reports that would explain perhaps what disease or treatment was most relevant to their diagnosis. So when they did this, we basically tried to put in a bunch of textbooks and documents that had information about horses and cats, and it turns out that maybe 50% of the diagnoses or use cases that this radiologist was working with were canines, or canine abdomens more specifically. So if we can build a very well-structured, very small vision of what that context is, so that the agent can only work with that information, we really reduce the amount of times or the risk that potentially like poisoning data can enter that context window. Completeness of answer, like we said before, when we're able to map everything into a graph, we're able to represent the full picture of something. I'm going to show you a visual of this in a second that helps you understand this, but getting a complete answer is as easy as just writing a different type of structured query in your graph. So an answer like, who are all my LPs? All I have to do is like say, get me all of the entities in my graph that are LP, and then relationships that are relevant to that type of question. Lastly, complex multi-hop querying in what we found to be a more reliable way. So instead of just telling me about all my LPs, we were able to then also add to this query, tell me about all the LPs who also have invested amount greater than X, and then who have certain rights where rights are this. These types of structured queries are easy to represent, but also easy to represent semantically, so an LLM can talk to these graphs in an effective way. So we started trying to build graphs in this space. We tried to really like implement KGs into our RAG pipelines. quickly for a variety of different customers, but we found that it's quite difficult and quite time consuming and painful at times to build comprehensive graph creation and management. So we really set out to make the solution that we wish we had to be able to do this. So we set out to basically create a tool that I'm going to demonstrate here in a second that does very small knowledge graph creation that you can just spin up really quickly with your own context, iterate until you have something that is like good enough to solve your problem. And then this is what you bring to your RAG pipeline. So our offerings, really it's focused on a few key areas. One is graph creation, management, and then orchestration. On the graph creation side, which I'm going to talk about today, we focus on helping customers build graphs very quickly from unstructured and, as of this week, structured text as well, but do it in 3 different ways. One from just raw data questions, one from schemas, and then another from structured CSVs. We also offer linking, so chunk linking, so the ability to map your nodes to raw chunks that are sitting in a vector data store or elsewhere to make much more explainable systems. Graph management, these are things like schema, graph management, backups, versioning, access control, and just all the things that you really need to implement and use graphs within your organization. And then orchestration. So this is all about like if you have a lot of different small knowledge graphs that you want to break apart and then use with agents in your RAG pipeline, what does that look like to be able to orchestrate that type of workflow? So we're building tooling to help you do much more structured retrieval of context on an agent per agent basis with these small graphs. So that these are things like complex query management, graph to graph tasks, and then just kind of structured retrieval from agents to graphs. Okay, so let's jump into a demo and just show you what this looks like today. Right now, the product is consumed primarily through an SDK, which I'm going to demonstrate, but we're also working on a UI to make this a little bit more usable. Okay, so what I'm going to start with is just creating a graph from a set of questions. So right here, what you see is just pretty much how simple this is to get started. All you do is import and initialize the WhyHow client. You can see here, you bring in your own vector database. In this case, we're using Zilliz. And what we're going to do is then upsert what is the first full book of Harry Potter. I think what actually it is maybe like the first half of the first book, but it's like some 200 odd pages of Harry Potter. But what I want to show you is how you can make a customized graph for this use case. So I've already upserted this into our namespace, which is just a logical separation of the data and of your schemas that you're building. And what I want to do is then create a graph within this context. Who are Harry's friends? What's important here is that we're able to create a graph that is hyperscoped to the things that you care about. In this case, maybe I have a certain set of questions in which I really care about, who's Harry Potter's friends are, what they do. I don't know, maybe I have a use case where that's relevant. So under the hood, what's happening is, so under the hood, what's happening is once the data is upserted as part of this add document statement, we're storing the raw text, we're splitting it, chunking it, cleaning it, embedding it in a vector store, and then we're using this question here, who are Harry Potter's friends, to retrieve relevant information to then map in that graph. From those chunks that come back, we're doing entity and relationship extraction. We're building triples from that data that are relevant to the question, who are Harry's friends. We're turning those triples into a graph, and then we're storing that graph in a graph database right now, which is Neo4j. So in Neo4j, I'm going to go here. Let's see. There we go. Yep, it's going to take, of course, it's going to take a few minutes to do this. Okay, I'll let this cook for a minute. But while this is happening, this is basically pulling in, like I said before, all the text that is relevant to the Harry Potter text, and then there we go. Now it's running. So what we should see shortly, come on. Okay, while that's cooking, I'm gonna let that run for a second. And I'm gonna come back to that, but then show you what the other process looks like now. So right now, that was what I'm going to show you in a second is that what that graph looks like for Harry Potter friends just in the question. But the other type of use case we have is quite similar, but also for just schema. So what you saw before here is it's going to basically pull out a bunch of text that is like similar, but like not very well structured for the type of use case that you want. So I'm going to show you what schemas look like. Great. Okay. So the other type of method we have is like graphs with schema. So in this case, we're going to do the same thing. We're going to basically upsert the document, but use a schema-based approach for pulling out information in a very structured way. So in the schema, I'm going to specify the entities I want to pull out. In this case, we say characters, magical objects, spells, locations, relations between these entities, which are basically the edges and the nodes. So maybe a character casts a spell, goes places, uses things, and then we specify the exact patterns that we want to represent in the graph below. So in this case, we have specific characters cast spells, characters go to locations, and characters use objects. So what we should see in here is basically a well-structured graph that shows those exact nodes and relationships. If we zoom in a little bit, you can see things like Harry uses Nimbus 2000, or uses the Philosopher's Stone, goes to Mr. Figs. There's a lot of different kind of interesting relationships that are sometimes pretty funny to look at, but also what I think was most important here is if you look over to the side where you have nodes and relationships, this maps to exactly what we asked it to build us in the first place. So what's powerful here is that you can then use this tool to have very well structured queries. If you ever tried to do this before, and I'm going to try to show you again with the other use case, if you ever try to do this with something like an existing solution that you may see open source like LlamaDex or on LangChain or anything in like the open source community, you can kind of throw some text at an LLM, say, find me triples that are interesting, put them in the graph, and you'll get a bunch of random things like, I don't know, maybe character flies on broom or character had possession of broom. In this case, we have very well structured specific relationships and entities that exist in here so we can more predictably and reliably query this graph. Okay, so last thing I'm going to show you is what we're now working on for CSVs. What's powerful here is that we're able to combine structured data with unstructured data. So I went ahead and ran this initially just to show what it looks like for us to do this with a very simple like newsletter, for example. So this is just like a single page of what like a Sequoia newsletter, for example, about like one person and the investments that they've worked with. We also have here with a CSV, which just shows really simple like set of texts about like people, the fund they work for, contact details, investments that they've made, et cetera. I built a very similar extraction template for this CSV and basically said, okay, for every column person, I want them to work at a fund as the relationship. I want to overwrite that fund and call it a company. Same thing for person with contact details and person with recent investments. So if I run this, we should be able to see this start to grow out from just the raw like PDF text and while adding much more structured context to it. So the power here is that we now have what is unstructured text from a PDF and much more structured text from a CSV that we can query the same way we would if it was just like a PDF domain extraction. So in this case, right down here, this article was specifically about this person and types of investments that they have. If we now go back down to the query section, we can ask things like, tell me about this person, or tell me about maybe more of the specific investments that they have. And what this should do is then go retrieve data from both that are both represented from the PDF as well as the CSV into this graph. So the main thing I really want to communicate through this type of technology is that we're able to help you go from nothing to graph really quickly. And if that graph isn't good enough for you, we give you the tools you need to get it to good. And this helps you build much more of a structured kind of graph-based retrieval processes. All right, I got about 1 minute left, so I'm just going to quickly plug some of the work that we did with Zilliz. You saw some of the work that we did before. We were using Zilliz as our solution for vector storage for both referencing raw chunks for explainability, but also for constructing the graph in the first place. This is another like non-graph related solution that helps explain some of the deterministic solutions that we get by using like very strong metadata extraction solutions and combining that with Zilliz. So I don't have any gift cards to give out, but please go ahead and like the repo when you get a chance. And this is also completely open source, so please download it and take a look at what it looks like to do more rule-based retrieval with Zilliz and with this type of a deterministic retrieval pattern. Just to recap, really great solutions and results that we've seen by implementing graphs into our RAG pipelines. Please come talk to us afterwards or hit us up at our website. We're doing a closed beta right now, so if you want to get involved, please let us know. We have a Discord. But yeah, please come find us afterwards. I'm glad to chat. Thank you.
All right, thank you. Any questions? I mean, I could listen to you for another hour. I mean, it's made it pretty clear to me that semantics matter, but yeah, relationships between these entities are also really important. Okay, let's start here first.
Thanks a lot. That was a very good presentation. Just a quick question. For the schemas that you define, do you have to define beforehand, or you let any AI model define it for you?
Yeah, great question.
Further.
Great question. This is actually something we're experimenting with right now. So I can actually show you in here. We have a way where we're doing kind of just automated schema creation now, where you just provide the document, or that's the wrong button. Let's see, generate schema. We have a way to do this now where we're just automatically generating a schema from that CSV, but this is exactly what we mean by leveraging LLMs to accelerate the pace at which we're making these graphs. You can take important questions from there, create a schema, and from that schema, tweak it a little bit more to make sure it maps to your exact thing that you want to be able to extract. So this is something we're working on right now, and it's a really great idea.
So you showed how to create graphs using CSV and unstructured data. Have you worked on any use case which uses only CSV or structured data, and then it uses LLMs to basically query that graph? So idea is like you have a huge database, convert that into a graph knowledge base, and then query it instead of using text to SQL, which can be a little more difficult and have less accuracy.
Yeah, well, I guess if the question is, can we create graphs with just structured data? The answer is yes, and that's actually fully deterministic. That's what's actually so great about doing this with structured data. There's many different ways to kind of decide maybe how you want your columns to map to different, let's say, nodes or properties within your graph. But as long as everything's in the CSV format, you tell us which cells or which rows should correspond to what pieces within the graph. It's a fully deterministic process, which is really great for accuracy. And then using LLMs to query that graph is very much the same process of doing it with unstructured data. But structured data is very quick and very deterministic.
Any other questions? Okay, cool. Well, I think we will be doing a lot of content with you because I think there's a lot of cool things we can build. One more question.
Yeah, so I just wonder, like, you use the large language model to extract the entity relationship, right, from the book, for example.
Yeah.
So how do you guarantee like the graph, like the relationship is correct?
If the question is, how do I guarantee that the
graph actually they are the real relationship?
Yeah. I mean, the LLMs are actually pretty good at this, and this is something that like we've done a lot of experimenting with. But you will see like there are actually there are often problems that come out of this as well. So if issues with like entity resolution or co-reference resolution, things where like he and his and Harry are often the same person. These are a lot of problems that do tend to pop up in this space that we are actively working with a lot of different like underlying machine learning solutions to fix and consistently improve. But what we can do is by having a very solid structure as to like or well-defined structure as to what these graphs should look like. We know that node entity types will be the same. Which entities from that data that get mapped to those nodes, that's a piece that is consistently improving. But the structure we know will always be the structure.
Okay. And also when you do the extraction, are you trying to extract the fixed just one relationship, or you will extract the multiple relationship? It seems like you only extract one type of relationship, right?
So maybe this will kind of, I'll flash this again so you can see. These are all the different types of relationships that we have between the nodes, right? And then like what we then do is specifically say exactly the types of triple patterns that we want to exist within this graph. So when we have this here, we know that only these types of patterns will exist within the graph. But it's these, I can't guarantee all of these will exist in the text, but I can guarantee that only these ones will exist in the graph.
And like then your graph model can only answer question related to this.
Ah,
regime, right?
Yeah, this is what we mean by really well scoped graphs. So
Okay.
if the idea here is like, for example, you maybe have a question, you in this case, this would really well serve a small agent that wants to know about a person has investments with different types of funds or different companies. So the idea here is that you'd have a very small agent with a very small task, which we believe is like probably the best way to use LLMs. And this is a very small set of data that works really well with to be able to only extract the information that's relevant to the task at hand. So if you want to answer other questions or build agents that are good at other things, we would say, let's build another graph that does it with only other types of data.
Okay, thank you very much.
So thank you for the presentation. So my question is about the updates. For example, I built the graph and then the document is updated, how it's reflected the graph and it's partial, iterative, or the fully built from scratch.
Yeah, there's a lot of different ways that updates can happen, right? So there's like maybe same schema exists, but new documents come in. That process is actually one we refer to as like, instead of ETL, it's ECL, extract, contextualize, and load. So we can then new document per the schema, pull out data, map it to the entities we pulled out. If a document under the hood changes, like a policy document changes, you want to remap that, that's effectively going to be a re-extraction and a recreation process right now. Now, I think there's ways that we can break this apart and do a lot more, like say, like fine-tuned or granular updates based on pieces of the document that have updated. But right now, for us, that's a kind of a re-extraction and rebuilding process.
All right. Thank you so much.
Okay,
And then don't forget to give them a star. I think it's a pretty cool project. So let's keep going into the ecosystem. And I think, you know, we've kind of bashed on LLMs a little bit, telling everybody how they hallucinate, but they're actually quite amazing. And we've got Lucy here to talk about exactly how LLMs are amazing, and they have a little bit of a different approach. I know all of us have touched, you know, the OpenAI LLM, but there's a lot of other LLMs, and she's going to share with us the LLM that her and her team have been building, and you know, some of the unique characteristics that Solar has. So welcome.
All right, everybody, good to meet you. So I do a poll every time I give a talk about Upstage. So how many of you have heard of Upstage before? Oh, all right. I see several hands. Okay. Now everybody will hear of Upstage after this talk. So yeah, today I'm going to talk about full stack LLM for inference use cases. Before Jiang and Chris talked about the whole RAG pipeline and some of the vector database components before. In this talk, I'm going to focus more on several use cases that we served before and about the components that we're building for the full stack LLM. So let me just go ahead and introduce Upstage. So Upstage is a B2B AI startup, and we say we're based in Seoul and the Bay. But to be more frank, we actually started, oh, sorry. Oh, why is that? Yeah. Okay. Okay. So actually Upstage started up in Seoul, and we have, ever since we were founded in 2020, we started our business in Seoul and acquired a lot of customers such as Samsung, Intel, Lotte, KT, and so on. And we kind of decided, hey, the world's so much big out there, we should definitely go out there. And US was one of the markets. Can you just turn your mic off on the laptop? Okay. Mute. All right. Okay. Okay, sorry about the technical aspects. So yeah, we decided that the market was much bigger out there, and that's why we decided to come to the US. And so now it's our 3rd month here, and we're looking for a lot of clients. We're meeting a lot of potential customers. So yeah, that's what's currently happening for us. We just raised our Series B, so now it's up to 100 million for us, and our flagship products are LLMs and document AI. And I'm going to talk more about that soon. And our customers range from SMBs to enterprises in finance, legal, bio, and some of the more domains. And oh yeah, my name is Lucy, and I'm the Chief Scientific Officer of Upstage. So about our journey for building AGI for work, we started as an AI company in South Korea. And during our first year, we met about 100 enterprises. We met the engineers, and we met the most high-profile people within AI companies, and traditional companies, and asked them what kind of problems they are solving. And can we solve that problem with AI? And are you willing to pay? So those were the 3 questions that we went around asking like 100 companies. And eventually we found that a lot of the companies were willing to pay for document AI, which is when given unstructured documents, a company wants to extract key values from those documents, saying the name, the telephone number, the address from a document. So that actually has a very popular use case when you're processing insurance claims. So in Korea, when a customer is actually applying to actually claiming for an insurance payment, they send a whole bunch of scanned documents. They take photos of the documents and send them to insurance companies. So those documents are mostly like receipts, medical receipts, diagnosis papers, and so on. And before Upstage Document AI, like several hundred people were typing in all these information into databases. So obviously, a lot of the insurance companies wanted to automate this process. And that is one of the use cases that we have with our insurance company customers. And while we were building document AI, guess what happened? ChatGPT came out. And a lot of our customers were saying, hey, LLMs are getting so big, and you are one of the best AI companies that we know of in Korea. Can you build us an LLM? And we were like, yeah, but LLMs are so expensive, and we're not really sure that we should do that. But when we were hearing their pain points, we figured that there might be a way that we can satisfy our customers by building LLMs. And that was by building purpose built LLMs, which means that for our particular use cases or domains or languages that our customers are interested in, we try to go beyond GPT-4 performance. But while we do that, we kind of make the model much smaller so that it can be much more affordable for us to train and for our customers to buy. So that is why that is how we actually evolved into serving LLMs. We call our LLM Solar and provide that to our enterprise customers. So those customers have several use cases that they need. Actually, at first, we had no idea what our customers wanted because all the use cases seemed very different. But then along the way of meeting our customers, we kind of found a pattern. That pattern is, so the customer use cases fall into 3 categories. First is process automation, like the claim automation process that I just explained to you. That kind of involves document classification or information extraction, sometimes de-identification, sometimes just extracting some names and key values from documents. Another is productivity enhancement, where they want summarization or writing assistance for people. Sometimes people call this copilots these days, and they kind of wanted these for just their members of their companies or a lot of experts in particular domains for that work for their companies. The third is knowledge search and discovery, where people wanted enterprise search. They wanted search among the documents within their company, or they wanted to gather insights from those documents, or they wanted to gather information from these documents in real time so that they can provide to customers that are outside of the company. And let me just get to specific details, 3 specific details for these use cases. So one was with Danawa, which is a e-commerce price comparison service with 10 million MAU within South Korea. And what they wanted to do was attribute value extraction. So by saying attribute value extraction, it means that given a product description like this here, you want to extract attribute values, like say the brand, the screen size, the color, the processor brand, and battery life, and so on, sometimes without a predefined schema, because all the products are very unique. Say electronics and clothing probably have different schemas, and if you want to define schemas per every product line, then that would be quite painful. So they wanted to do this for price comparison. So like, when there's a laptop, a lot of different vendors upload the same laptop to websites, to e-commerce engines. And these all have very different descriptions. So these price comparison engines, they hire, like, again, several hundred to several thousand people to match these different products to say, hey, these 2 products are the same, these 2 products are different, in order to set up their price comparison engine. So they kind of wanted to automate this process, and they came to us and asked us to build a e-commerce purpose-trained LLM. And so we built a 30 billion custom MOE LLM for on-premise use, which eventually had almost 90% accuracy in this task, which was much better than other models out there. And so our customers were very satisfied. Another was a very interesting use case where since we have worked a lot on document AI, we have a lot of experience handling claims, insurance claim documents. And this one regarded LLMs, and which was very interesting for us. So what our clients said, that they have lawyers that take almost 40 hours to take care of one insurance claim. So that sounds very expensive, right? So what they want to do is they want to summarize all these medical bills, insurance claims, and legal documents, and put up a summarization, sometimes like timeline summarizations for these lawyers, so that they can handle one claim in like less than 20 hours, which is 2 times the performance that they previously had. So for that, our tech stack consists of document AI and Solar LLM. We call that full stack, in order to create the summary of patients' medical history and plan of actions for the lawyers. Another is also in the legal domain. We have a partner called Law Talk, and they also had this problem that they wanted an LLM that understands Korean legal documents, but they used all the LLMs out there, and they figured, hey, LLMs are very strong in English and particularly in general domains, but for Korean, like in Korean legal, it doesn't work for us. And so they came to us, and they gave us all their documents, and we built up an LLM for their use case, and And now they're actually using that in their own RAG pipeline. So to come to this, let me just briefly tell you what Upstage Full Stack LLM is. So in order to solve these use cases, we built up this idea called Upstage Full Stack LLM, where when a user has structured data and unstructured documents, we want our users to handle it all with LLMs. So how we connect that is when structured data goes directly into relational databases and NoSQL DBs, we also process the unstructured documents and put them through a key information extractor if you have a predefined schema. And we extract the names, telephone numbers, and so on, and put them into a relational database. If the customer doesn't have a predefined schema, then we turn the documents into a layout analyzer where we just convert the PDFs or PPTX into an HTML file so that the LLMs can actually read the PDF document. So right there, the layout analyzer is, we focus a lot on tables because we know that LLMs are very good at processing text only, but whenever they encounter tables, we know that they have a lot of confusion. So after that, we chunk the document into several pieces, put it into an embedding model, and then send it to a vector database like Milvus, and retrieve, use our Solar generative model. And I'm going to talk more about the groundedness checker later on. And then the user finally gets the results. So I mentioned that I'm going to talk more about components rather than the whole pipeline, because that's what Upstage is currently focusing most on. So we believe that you don't really need a gigantic model to solve all the business use cases. So we want to focus on particular domains, languages, or tasks. And that's why we're building Solar Korean, Solar Thai, Solar Japanese, Solar Finance, Solar Medical. And these are very popular among our customers because they want more powerful but more affordable models. And so we're focusing more on the intelligence layer, and that also indicates that we're building layout analysis, embedding, groundedness check, and key information extraction models that I just pointed out before. So our customers want these models because first, they want their data to be safe. So a lot of our customers want on-premise models. So we are able to serve our models through the cloud, but also through on-premise environments. So that is one of the reasons that our customers really like us. The second is that our models are much cheaper compared to the ability that the model has. So as I said, our customers expect performance beyond GPT-4 on particular use cases, and not everything needs to be general purpose. So now I'm going to tell you a little bit about our components. This part will be quite quick, so that you can also experiment with our components after you go home. So let's talk CRISPR, because I am a novice in bio. I don't know anything about bio, but I want to know about CRISPR because it sounds so hot. So I want to ask, what is CRISPR in layman's terms? And I want my tutor to answer, CRISPR is blah, blah, blah. And so I'm going to introduce some methods to do this, also introduce some tools on the way. But since everybody was talking about RAG, I'm going to be very brief on this. So the first method is you can just simply ask an LLM. The premise is that the LLM has to know everything. So, but it mostly doesn't know everything. It sometimes hallucinates. So this is probably not the best method. But this is very easy. You can just ask questions to Solar. Our Solar model is comparable to GPT 3.5, yet 3 times faster. And we use this model as the base model, and then fine tune it or continue pre-train it for different domains and so on. So it is very easy to use. You can just use LangChain and just send a message to our Solr model, and it's going to answer CRISPR as a gene editing tool and so on. One of the powers of Solr LLM, one of the distinctions is that it excels in English and Asian, particularly in Japanese and Korean. So MMLU, Japanese MMLU, Korean MMLU is all much better than Llama 3. And the second method is that you can also condition on a document. And if you put in a document, you're expecting the generative model to answer with contents within a given document. So this can be done in 3 simple steps. You first download a paper from the web, convert the PDF to HTML, and use an LLM to ask questions. So let's say we've downloaded a paper from the web. The paper here on the right is a paper about CRISPR. If you see, the paper has 4 pages. It has 3 columns, and it has figures. This one doesn't have tables, which we're really great at, but it could have had tables. But in general, in overall, this paper is too complex for an LLM because LLMs, are large language models, so they can only handle text. So that's why we want to convert the PDF to HTML, which is all text. And so it's also very easy to use our upstate layout analysis loader to convert the document into HTML. You want to use our layout analysis because it's one of the top class layout analysis tools out there. There are actually several that you can choose from. The element serialization accuracy goes up to 95%, and it excels in multi-form table extraction. Like typical tables out there have merged cells, and they have hierarchical headers, which makes LLMs a very hard time to understand. But we convert that successfully into HTML. And then you can ask Solr using the document QA. And I don't know how many of you have had the problem of having an LLM answer something, and then you have to go back to check whether it's wrong. Actually, I encountered that a lot during my work and when I was working with LLMs. And that's why we made a groundedness checker. We wanted to automate that process for you. So this groundedness checker, if you ask it, given a document, it will check whether the answer and question complies with the document. So you don't have to, scroll your answer, check whether it's in the document or the LLM is hallucinating. So that is another tool that we built. And the last is RAG with a vector DB. So previously we were conditioning on one document, but sometimes that document can go beyond a given context length. And a lot of the LLMs out there have a given context length. For Solr, it is 32K. Some of them out there have like 1 million. But anyway, there's a context length. And if you have documents beyond that context length, you can't do QA on it. So in that case, you want to use an embedding model and a vector database. And that is why I'm suggesting method 3. You can use upstage embeddings for this. And also, if you use Milvus together, you can retrieve in under 10 lines of code, around 10 lines of code. And yeah, that is what I was trying to show you today. And to wrap up, there's a lot of use cases out there that are really exciting. You can use a lot of the components with Upstage and have fun building your RAG components. Thank you.
Any questions? I'm assuming that it also works with English law as well, because in that table you said.
Right.
Okay.
Of course.
Cool. Excellent. All right. Oh, we have a question. Cool.
thanks for the talk. So question is, when you train, excuse me, when you train Korean models or Japanese model, how big is the token size or the text size in overall to train those LLM models compared to English text?
That is a very good question. It always depends on our customer's budget because we work with customers. But we typically say that when we're expanding to one domain or language, we at least want 1 trillion tokens.
Cool. Any other questions?
Thank you for the presentation. I'm trying to understand what is the rationale behind converting the PDFs to HTML? What is the biggest benefit?
Right. So now that there are multimodal engines out there, if you have a multimodal engine, you don't really multimodal LLM. I'm saying, then you don't really need a HTML converter. But if your LLM only understands text, which is a lot of the cases for our customers because they only train on text instead of images, we kind of want to turn PDFs into HTMLs because I don't know if you've tried using PDF text extractors, but they jiggle up all the text within the document. So the output is totally, you can't comprehend the contents. So we kind of wanted to keep the structure, especially the tables, because tables have very valuable information in them.
Any other questions? Sure. What I appreciate about some of the examples that you presented is that they're real world use cases, and that's where usually things trip us up.
Very quickly, since you mentioned this, LLMs can be used for domain specific. So if somebody wants to, if I want to expand to a different domain, I can adopt this one, right? Use your developer AI.
Yes.
Try it out.
Yes.
Okay. Thank you.
Cool. And then do you guys have a Discord channel or a community forum that everyone can go hang out with you?
Yeah, actually, you can come to upstage.ai. That's our website. You can also search Upstage AI in Discord. We also do have a Discord channel. We have a Twitter, LinkedIn, everything you can imagine. So just search Upstage AI and you'll find us.
Cool. Let's give her a round of applause for this great talk.
Thank you so much.
Okay, so we're gonna do a little bit of networking, and then Christy is our developer advocate who was busy with a community member earlier, but she's just gonna share who the winners are for today's raffle.
Hot tip, log into your GitHub, and even if you were at our event last night, go ahead and, this sounds dangerous, go to the Milvis repo, unstar, and then star. And then you'll show up again, and then just to make sure you show up for the raffle.
Do it right now?
Yeah, sure. Yeah, let's give him about 30 seconds.
Lucy.
Yeah, log into your GitHub, unstar, and then star.
For the Gen here. So we have a.
You mean a SAP?
Yeah,
Oh,
SAP.
yeah.
I have certain questions. I'm not bubbling. Okay.
All right, ready? Can we just go ahead and look? Everyone done with that?
I'm gonna refresh just to make sure I got everybody. Okay, I see a few more names.
So as we're waiting for that, we need to drop off our lanyards at the front for the SAP folks. So just a little bit of housekeeping. All the talks will be posted on YouTube. So Sashi will do a quick edit. And if you're keen on specific topics for the next meetup, just let myself or Christy know. Or if you want to talk at any of these events, let us know. And then also we make sure that the notebooks also get shared so you can play around with stuff. Are we ready?
I already got. Yep, I already got. I don't know if anybody can see. No, you can't see my screen. Okay, so take my word for it. I'm spinning a dial. Is T it is Tina Guy 57 here? Okay, I'm gonna spin again. Is Raphael Riemann here? Oh, winner. Okay.
Two more, okay.
Is H.S. Kendall here? Yay. Okay, last one. PK1U. Okay. HT Zoo, ZHU. Tian Peng Fei. No? Okay.
Okay, winner, come on.
SN Lee. SN Lee?
Oh,
Yay.
Thanks. We'll see you at the next one. And then we have to break it up. So that's why we went to talk about it. Oh, we actually are. Yeah, we're trying to like people up.